for our multiple regression example, we are going to use this hypothetical data set and then questions. We are going to predict scores on a physics achievement test based on the 5 independent variables: IQ, EI, BSAT, and MSAT, as well as gender. So one dichotomous variables coded as 1 and 2, and then other are the quantitative variables. So the research question is how well scores on physics are predicted based on the 5 variables, which are independent variables. So we go back to our SPSS data file. We have several variables here, but we are choosing only physics and then 5 of these variables to include in the equation. So we go to analyze, regression, linear. So physics is our dependent variables, and then we are going to select 5 independent variables as said in the questions: gender, EI, IQ, verbal, and math. So 5 elements are included under independent, and then 1 is dependent. Now we are going to choose these options. Click statistics. We will choose estimate, confidence interval, always 95, and descriptives, part and partial correlation, collinearity. Continue. Plots, we definitely like to have plots. So this one in the Y, this one in the Z, X. Maybe we can check the normality plot probability as well. Click continue, and we can leave the other options as it is. Click on OK. Now we have descriptive. So this is 195, the number of the sample. Correlation. So in the descriptive statistics, you see the 5 variables that we used earlier, and all of them have 195 sample size, which is a moderate sample size. Now if you look at the correlations, variance variables enter. This is the enter method. So we enter 5 variables as in independent and the dependent one physics test score. So we go to the model summary. This is the important one for us. So if you look at here, we usually look at the R square and adjusted R square if you have a small sample size, meaning less than 50 or 40 or say 60, then we use adjusted R square. But in our case, since we have 195, we are going to use R square. So you have 0.805, we always multiply it by 100, so it will be 81% of variance can be explained by all the 5 variables for our dependent variables physics. So this is a strong prediction, very respected result. Adjusted R square is used when you have a small sample size, and you may use it. So now the next important is the ANOVA table. This will tell us the level of significance, if your result is significant or not. You have here 0.00, which is less than p value 0.001, meaning in other words, this result is statistically significant. So that means we can predict physics test score based on the variables math, SAT, gender, emotional intelligence, verbal scholastic ability test, and intelligent IQ. Next, we want to see the coefficient. In the coefficient, we have an individual. This is important because it predicts the coefficient will tell us which predictors is important in the equation, or what is the role of each predictors, each independent variables. So usually we look at the standardized coefficient beta value, not the unstandardized. Just look at the standardized value. If you look at here, all of them have a small value except this one, BSAT score. So here also look at the level of significance. So if you look at the gender, is statistically significant. This one is more, p-value is more than 0.05. Here is 0.658. This is not statistically significant, and this is also greater than p-value 0.05. So this is also not statistically significant. Now the other one, BSAT score, here you see there is less than 0.001, and the other one, the last one, math SAT score, is also statistically significant. So in other words, in the equation, multiple regression equation, we have important roles of gender and BSAT and math SAT score. And the other important things to look at in the coefficient is the collinearity statistics. Use one of the other, tolerance or BIF. Variance inflection factor is similar with the tolerance. So let's look at this first. A BIF of greater than 5 is generally considered or is an evidence of multicollinearity. So none of them is, or all of them are less than 5, so that means there is no problem of multicollinearity. The tolerance score also indicates the same thing for us. Let's for this one, if you look at here, 0.713, 1 divided by 0.713 will have the same score. Let me pull out my calculator and then show you. So 1 divided by 0.713, if you calculate this one, you will have the same results here, 1.402. so use one the other. Next step, look at the chart, and if you go to the chart, the p plot, all the variables are in the vertical lines around this line. That means this is the better one. And if you look at the scatter plot, all of them are in a square, meaning the variables are around the center, meaning these residuals are good predictors of the main dependent variables. The final step is you have to report the results of SPSS in the language. So this is the outcome. We have explained them. Standard multiple regression was performed to examine how well scores on physics were predicted by entering all 5 independent variables into the equation. There was no evidence of multicollinearity as a VIF value was less than 5. The combination of 5 independent variables significantly predicted physics score. This indicates that 80% of the variance in the physics score was explained by the model when all variables were used. To assess the contribution of individual variables, individual regression slope, that is standardized coefficient beta, were examined. 3 of the 5 predictors were significantly predictive of the physics score, that is gender, BSAT, and MSAT scores. The negative sign for the slope for the gender indicated that the higher score on gender, that is being female, predicted lower score on physics. The higher score on VSAT score predicted lower score on physics. MSAT was the strongest predictor of the physics. And the 2 other variables, EI and IQ, were not significant related to physics. This is important, how to bring the model summary and the ANOVA into your report. So the F value is coming from here. The degree of freedom 5 in 189, 189, and 155.83. That's from here. Now the p-value is just from 0.000. That means less than 0.001. R and R square, that's coming from the model summary. R and R square, adjusted R square also there. if you look at the earlier part. So we are reporting all of them, and now the next part is important, which is the reporting the significant or not significant part of the your standardized beta value. So all the beta values are reported here. MSAT score is 0.881, which is the strongest one in the equations, and you will be reporting the model summary, ANOVA, and the standardized coefficient beta in a table, APA format table. Make sure that these symbols are italicized: F, p value, r square, and then make sure also the space between these equal signs. So we have enough space in between the numbers and then the words, letters. So all the numbers, the words are italicized: F value, p values, r square. That's it.